thanks for stopping by Pete's Garage. Well, I want to start out first by saying Happy New Year to everyone. This is my first video of 2019. There's going to be a lot of great videos coming up. I have tons of stuff to give away throughout the year, so I'll have a bunch of videos coming up pretty quick. And I also want to say I hope you had a great holiday. I hope Santa brought you all the car parts you wanted. Maybe some nobody knew you were getting, but I hope you got everything you wanted. And I wish you health, safety, and happiness throughout the entire year coming up, 2019. Now, I'm going to do something. I have a bunch of video series going on, but I'm going to share something with you real quick, a short video here. Many folks ask me, and when I put engines together, I put the cam in the engine after the crank and the pistons are installed. And the most common comment is always install your cam first, put the block sideways, drop the cam in. That's the #1 comment. And my reply is, well, at the factory, they install the cam after the crank and the pistons. The reason why I do it and the reason they do it is because if you have the camshaft installed first and you're putting in your pistons and your rods, if you were to actually drop, if you had the cam in first and you dropped a nut or a rod bolt or a bearing fell out and it fell in it, you could nick the cam. So why have the cam in place while you're still assembling parts? So I put the cam in after the crank and the pistons. Now here's a short video of an automated cam installation that I found. It shows when you have a block, the block is machined and the cam bore is bored straight through the block. So if you were to look through the block, the cam bore goes all the way through the back, and of course a cap gets put on the back of the engine. So in this video you're going to see an arm reaching through the block. It's going to mate up with the cam, which is on another arm, and it's going to bring the cam into the engine, and it's going to be rotating as it goes in. The reason it's rotating is because there's an oiler on the escapement, and it's putting oil on there as it goes in. So let's take a look at that real quick. Here you can see the arm coming in. There's the oil rotating, and insert the cam, releases, and it drops the engine, and it releases it to go down the assembly line. That's the way that works. So that's why I say that's the way the factory does it. That's why I do it. Now, the next thing. When the automotive companies, and this is probably going back maybe close to 20 years, when they stopped using gaskets, there's no longer an oil pan gasket. You won't have a front cover gasket. If you have a bed plate which separates the block from the lower part of the engine with a bed plate, there's no gasket there. It's all done with RTV. And if you ever wonder how they apply that, who puts that bead of RTV on? Well, it's done by robot, and it's done pretty quick, and it's really cool. And I've also found this video to show you how it's done. What basically happens is the RTV is delivered in huge 55-gallon drums, and through very high pressure, it's fed through these lines, and it's extruded through these nozzles, and the robots apply the RTV to the block. This is on an oil pan for a, what is it, 2.4 liter GM engine, I think it is. So let's take a look at that. Here you see the robot just comes in, drops down, applies it in two directions, two robots, each does a half, and it comes up, and it's done. It releases the engine, it goes down the assembly line. I think that does that in roughly 24 seconds, 24 and a half seconds. So every 24 and a half seconds or 25 seconds, something like that, they're applying the RTV and it's going down the assembly line. That's how that's done. Now, now this is going back at least close to 30 years ago. The auto plants, engine plants, used to test engines after they were finished by actually starting them up. There would be an area in the plant where the engines would come after they're assembled over by conveyor. They would be taken off, put on an engine test stand, they'd get hooked up, and they were actually started up first time with natural gas. It wasn't gasoline, they were fueled with natural gas. And then they had a bunch of guys working in the area, and they would test it and listen for problems, make sure it was running properly. So they would do, it was really pretty cool to see. But you can imagine that's a lot of work, starting an engine up, and then after there was a problem, they would send it to a heavy duty or a tear down station. If there was something wrong, they'd fix it, put it back in. And that is why engines that are, I'll say 25 years or older, so what is it, 2019 now, so engines built before, let's say, 96 or so, they were tested. They were actually hot tested. And that's why engines, before then, you had problems with leaks or problems with the engines, and older engines really didn't you might have had a bad engine. It's because it might have gotten torn down, it might have gotten repaired. And when it's sent to that area, it's common that it might have more than one thing wrong. It gets sent to that area, the person only fixes the one thing, and it might go back and forth 5 or 6 times. Well, guess what? That's expensive, and it doesn't make sense because you're going to let problems get out of the plant or quality issues get out of the plant. So what they started to do is something called cold testing the engine. And what they do is simply, the engine goes into a station. It's a very big enclosure. The engine gets clamped. You'll see the pallet raise. It gets clamped down. The engine gets held. And all of the sensors come in. Now that vehicles or the engines are all run by computer and all the sensors are all over the engine, you have all of these automatic things come in to hook up to the sensor. So you're going to hook up to this engine. You'll hook up to the top to the oil control valves, the crank position sensor. You're going to hook up to the oil temp, oil pressure, the water temp. All the spark plugs get hooked up to. Anything that can be tested on the engine gets tested. Then there's a very large drive that comes in and gauges the crankshaft on the flywheel, and it spins the engine with a giant electric Indromat motor. As the engine is spinning, it's spun to make sure there's oil pressure. As soon as there's oil pressure, you'll see it speed up. It'll speed up to high RPM, and it's testing the engine. It's going to test all of the sensors as it would in your car, and then it slows it down to make sure that it's still running, and then it stops and it goes on. You're going to see that happen. So let's take a look. You see the engine come in, raises up, all the sensors connect, and here is where the Indromat starts to drive the engine, and then it will speed up. You see the engine slow down here. What's happening is it's testing the intake and exhaust pressure, looking for leaky valves, nicked piston rings, functioning of the entire intake system, fuel system, making sure the fuel injectors are working right, and it tests all of that. So that's the entire cold test process, and that process replaced hot testing. It's more effective, more efficient. You don't have to run the engine, and you're positive that it works. And it's extremely, extremely sensitive. It's amazing the things that can be picked up at cold test before the engine leaves the plant. It picks up things that you would never catch up hot testing. When you run an engine, hot testing is loud, so you don't really hear everything. These things have accelerometers on it to detect motion, vibration, noise, microphones sensing noise, and it'll catch anything before it gets out of the plant. That is why the quality of engines have increased over the last 20 years, is because the equipment and the machinery used to analyze it before it gets put in a vehicle the technology has exploded, and it's extremely accurate and it's extremely sensitive. So that is why you get better engines today than you did a long time ago. Hope you found that interesting. Again, I got a lot of great stuff to give away coming up, and working on the Cobra right now, so I got some more Cobra videos coming up. Got a bunch of great things coming up, and I hope we have a great year together. Thanks for stopping by Pete's Garage.